Previously, you learned about measures of central tendency. Today, we're going to learn about stem and leaf plots, which is just another way to organize a set of data. So, depending on where you go to look for the definition of stem and leaf plots, whether it's online or your textbook, you might see a varying definition. But the definition that we're going to go with for stem and leaf plots is a system used to condense a set of data where each data value is placed into either a leaf, which is usually the last digit, or into a stem, which are the other digits. Now, the reason why I said it's placed into either a leaf, which is usually the last digit, is because your textbook has a different definition. So, how we will be using the stem and leaf plot, on the left side we'll have our stem, on the right side we will have our leaves. So, for example, if I wanted to organize the number 13, my stem would be the tens place, which is the 1. The leaf would then be the ones digit, which is the 3. Now that works for a 2-digit number, but if you had a 3-digit number such as 113, my stem now becomes 11, so the first 2 digits, so up here it says the other digits, so that would be the first 2, and then the last digit, which is your ones digit, would be the 3. So to identify which is which, every stem and leaf plot will have a key, and the key will look something like this. 1 with a line and 3, which represents, in this case, 13. If I wanted to represent 113, that would be 11 with a line and then a 3 for 113. Now, according to your textbook's definition, stems would still go on the left, the leaf would still go on the right, 13 would look the same, so 13, the tens place would be the 1, which is your stem, the ones digit is the 3, and that is your leaf, but then for 113, your stem would still be 1, and then now your leaves becomes the 13. So again, this is the way that we will go about for our purpose. So let's take a look at the first example. It says create a stem and leaf plot for the following set of data. Now, one way that you might want to start the stem and leaf is to list all your numbers out from least to greatest, kind of like what you would do if you are trying to find the median of the data set. It becomes time consuming. You don't have to do it in that fashion, but it might help you later on down the road. So the first thing I want to do is I want to identify the least value. So if I look through the set of data, I have a 45, nothing smaller there, 41 is smaller, and then 40. So this is my least data value. So for my key, I'm going to say that 4, which is the tens digit, slash 0 represents 40. So I'm going to start my stems with 4, and now I'm going to look for my greatest value. So as I go through here, 98, we have a 97, but 98 is still larger, so 98 is actually going to be my largest value. So I'm going to order my stems from 4D all the way through 90. Okay, so my first leaf will be 40. So I'll cross that out to know that I used that. So then when I look for my next value, I have a 41. Next one after that would be a 45, so putting the ones digit to the right. Then I have a 47, and that's it for the 40s. Then looking at the 50s, I have a 52, so I'll put a 2 there, another 52, I have a 56, and another 56. Into the 60s, I have a 61, I have a 64, another 64, so I'll write that down twice, and then I finally have a 67. Into the 70s, I have 70, 78, and 79, so I'll put down an 8 and a 9. Into the 80s, I have 180 and a second 80, so put down 2 zeros. I have an 82, an 86, and then into the 90s I have a 97, and finally I have a 98. If you notice, I did leave one out. It's 59, so I can go ahead and add that one back in. So eliminate that. And now to verify that I've got every number, although I crossed them all out, I can just count up the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So as I go through 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. So I do have all values accounted for, and this is what my stem and leaf plot looks like. Now, the reason why stem and leaf plots are nice to work with is I can easily identify my range. So I have 98 all the way down to 40. I can identify my median right away. So if I have 22, an even set of data values, I want between the 11th and 12th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, my median would be 64. It's also nice to identify modes. You have 52, you have 56, 64, 80 as your modes. Next example. So in B, again, what we want to do here is we want to first identify what our smallest value is. In this case, looks like we have 13. So for my key, 1/3 is going to represent 13. If I identify the largest value, that is going to be 92. And so I'm going to list the stems from 1 all the way to 9, representing 10s all the way through the 90s. Alright, so I'll first put down my 13. Looking at the rest of the values, I have a 17 and I have an 18, so I need to add in a 7 and an 8. Into the 20s, I have a 21, I have a 27, I have a 28, and another 28, so I'll put down 2 8s. 30s, no 30s are accounted for, so I'm going to leave this space blank. Into the 40s, I have a 45, I have a 49, and another 49. So 2 9s will be put in the next to the 4s. Into the 50s, I have a 50, a 53, and a 53. I have a 55. And now into the 60s. For the 60s, I have a 66 and a 68. Into the 70s, don't have any 70s listed here. In the 80s, I have 80. I have an 81 and another 81, an 83, and an 86. And then finally in the 90s I have 92. So this is what my stem and leaf plot would look like for this set of data. Now what I want you to do, go ahead and pause the video. I want you to try the U-tries, so problems C and D, on your own. Be careful, we have 3-digit numbers for each of those, so if you need to, go back and refer to what we do if we have a 3-digit number. Alright, so for C, this is what your stem and leaf plot should have looked like. Remember, we are going to first identify our key. Our lowest value in this case was 101. Our highest value was 148. For problem D, if you did this correctly, this is what your stem and leaf plot should have looked like. Our smallest value is 114. Our largest value was 158. Example number 2. Here it says use the stem and leaf plot to answer the following questions. It says the ages of people at your family reunion are given in the stem and leaf plot. So here is the set of data that we have. Here is our key, so 2/8 represents 28 years old. The first question asks how many people attended the reunion. So what I want to do is I want to count the number of leaves. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I had 14 total people attend the reunion. The oldest person, or how old was the oldest person there? The oldest person was, look at our last leaf of our last stem, so that would be 41 years old. Suppose that your 98-year-old grandfather attended. Why do you think his age would be an outlier? Well, if we look at the whole set of data, we have a person that is 3 years old and a person that is 41 years old. So the reason why your 98-year-old grandfather would be an outlier is because 98 is much, much larger than 41. In fact, most of your data falls between 10 and 40, or actually 41. So what I'd like you to do next is I'd like you to pause the video and go ahead and try the U-try on your own. When you've completed the problem, I would like you to go ahead and unpause it and then check to make sure that you have the correct solutions. If you've done this problem correctly, you should have gotten that the mean was 26, the median was 29.5, the mode was 2 modes at 10 and 35, and then the range for your data is 41 minus 3, which is 38.